Hello everybody. So what I thought I'd do today is actually just do some live coding and some experimentation using Python and 3D modeling with cadquery. And cadquery is built on top of Open Cascade, which is the page I've got open here. Open Cascade technology is a collection of C++ libraries that together constitute professional computer-aided design kernel modeling 2D and 3D objects. Now, you don't have to be a woodworking specialist or somebody who works in a factory to get some benefit from this. There's all sorts of overlap, and for one thing, it's probably a good way to familiarize yourself with NumPy 3D arrays working in X, Y, and Z 3 dimensions. So whenever you're working with arrays, basically a 3D NumPy array is effectively X, Y, and Z coordinates, which you can apply to any form of three-dimensional modeling, whether that's CAD, computer-aided design, whether it's game development, or even if it's something to do with spatial recognition. It's endless. Anyway, let's have a look at cadquery. In my last video we briefly touched upon it, but I feel like I skimmed through it and I didn't really show much trial and error experimentation with the code. So as mentioned previously, you can build parametric 3D CAD models. So without further ado, let's dive straight into some code, which is one of the examples from this site. It's not the one I showed you yesterday. It's a bit more simple than that, because what I want to do today is actually just code something as we go along and modify it, break it, modify it, break it until we get what we want, until we understand how to build something from scratch. So what we've got is the example code. I've got it open in Vim on a Linux Mint PC in a Conda environment, and let's just exit that and I'll just clear the screen. And what else have I? Yeah, so to run, I'll show you the three things we're going to be using. We're going to be using cadquery, which is installed into Conda, as you can see on the left here. gmsh, and you can install that with pip, I believe. I think I installed it with pip. And that lets you view your output files. When I say output, as long as it's an STL, I'm using STL. There's no real preference here. You can use VRML. You can actually create an SVG, scaled vector graphic image. Yeah, also DXF, drawing exchange format. So there's all sorts of output formats that you can get using cadquery. So we're using cadquery, gmsh to view the output, and stop it! I don't know what happens there. Sometimes, my mouse is, I think the batteries in my mouse are going and it's doing crazy stuff. Excuse me. Yeah, so conda activate cadquery. That's me opening up my code in Vim. That was how I installed cadquery, and I used cadquery equals master because that gives you the newest version. All the documentation's on the cadquery GitHub page. And let's go back to where I was. Yeah, Python version. My installed Python version is Python 3.9.6, but for cadquery to work, you need to use 3.8, which is why I've done this. So let's get back to where I was, which was cadquery 2. And right, so from the top, use Conda with 3.8, import cadquery as CQ, from cadquery import exporters. Now the exporters bit is optional, but obviously if you're going to be doing anything useful, you're going to want to export what you create rather than just view it. If you want to view it in the screen, you can actually run all of what you see here. You can run it within Jupyter Notebook. And there's also a version of cadquery which has its own GUI. It's cadquery GUI, which lets you view what you're building as you go along. I'm a bit old school, and because my ultimate aim of this is to do it all headless effectively, this is all pretty much going to be done in code until we get to viewing the output at the end. Length 80, height 60, thickness 10. The dimensions of the box, these can be modified rather than changing the code. Changing the objects. Oh yeah, they're just setting up variables. And then they're putting a hole in center hole diameter. So what we're actually creating is a square block with a hole in it. You've got to start somewhere. So result, this is effectively the object which is created by cadquery using the information above. So cq.workplane. So workplane is, you've got 3 planes in, well, you've got 3 dimensions. So the default for most 3D modeling to begin with is your XY plane. Box. So then we use the dot box method and we specify the length, the height, the thickness. So that's creating our box. And then the faces. There we go. The faces, we're saying if it's greater than the Z face, I believe. So X, Y, and then Z. So in the 3rd dimension, we want to drill our hole. Let's just run this, and then we'll come back and modify it and see what happens. So Python 3 cq2.py. Takes a couple of seconds. When you see the file it creates, it's doing a lot of work. And then I'm actually making a file called moo. And there we go. That's our 3D model of basically a rectangle with a hole in it. And you've got to start somewhere. Let's just go back in and modify that then. And let's see if we can break it. So instead of doing the hole on the top, let's do a 2mm hole, but do it in the side. And let's change that to should we do it in the 80 or the 60 face? Height and X, Y, Z. Height is 8 is 60. So let's do it in the Y plane. So replace Y. Run it again. And this time the hole should be coming through from the sides rather than down from the top. This may seem a bit old-fashioned way of, yeah, there we go. So we've now got a hole, and if we get it right, yeah, you can see daylight through the middle, look. See that? We've actually put the hole in the side of the piece of wood rather than in the top face. Yeah, as I say, this might seem a bit old-fashioned, but again, with much command line stuff, it seems old-fashioned and going back to the dark ages, but it's how you automate stuff. I don't think that's any groundbreaking news there, but it just needs saying really, because you want to do something without having to look at your screen, then automate it, command line. Okay, so let's bring up another example. I think we've got the maximum amount of value from that. So quick start. That's the cadquery GUI editor. Might come back and look at that, to be honest. So there we go, similar to the part I was just making, but we've got additional holes there. Start with a single simple plate. So that's what we just started with. That's what we just made. A plate. And before I moved the hole, that's what we had in the first example. Let's just read some of the notes. Your block should look like this. Code is pretty compact. Let's step through it. Line 4 adds a new parameter, diameter, for the diameter of the hole. Okay, that's the bit that I changed to 2 millimeters so that it would fit in the side. Line 8, we're adding the hole. cadquery.workplane.faces selects the topmost face in the Z direction. And then cadquery workplane.workplane begins a new workplane located in this face. The center of this workplane is located at the center of mass of the shape, which in this case is the center of the plate. Finally, cadquery.workplane.hole drills a hole through the part 22 millimeters in diameter. So, dot hole. That's quite memorable. If you want to make a hole, use dot hole. Moving on, we've got another example, but we'll have to repeat the above step 8 times to get counterboard holes. Good news, we can get the job done with just a few lines of code. Here's the code we need. So same block height, 60, 80, 22 diameter hole, thickness 10. Make the base. So all that is what we had before. And what we're adding now is padding. Okay, so counterboard hole, 2.4, 4.4.1. Those look to be the different diameters because you've got a large diameter hole and then a smaller diameter hole inside. There we go, let's read the description. There's quite a bit going on here, so let's break it down a bit. Line 5 creates a new padding parameter that decides how far the holes are from the edges of the plate. Okay, padding 12. So here, this hole, or the center of this hole, 12 millimeters in from that edge and 12 millimeters in from that edge. In fact, in case this is too small, let me just bring up a KMag. There we go. Put it down there. Is that better? I hope so. So yeah, padding equals 12. Next, line 10 selects topmost face of the block. So yeah, faces equals Z. That's a bit flickery, isn't it? I'll get rid of that. That's one of the issues. I think it's because I'm using OBS as well. It makes the screen flicker. That's what you get with a 7-year-old, 8-year-old computer. Right, where were we? So workplane, Z. If you look down here, you've got the legend. So let's just zoom in on that a bit. Z. So vertical is Z. So that's why up here we're choosing face Z. Then what's happening on line 11? Let's have a look. The cadquery workplane.rect function draws a rectangle for construction equals true. Tells cadquery that this rectangle will not form part of the solid, but we are just using it to help define some other geometry. Okay, so that's if you're in your workshop and you're just getting a pencil and you're marking out on some wood. Just to help you find center points and Unless you specify otherwise, a rectangle is drawn with its center on the current workplane center. In this case, the center of the top face of the block. So this rectangle will be centered on the face. Okay, so our construction rectangle, can't say rectangle properly. Rectangle. So the construction rectangle is put on top of that block. Line 11 draws a rectangle 12 millimeters smaller than the overall length and width of the block, which will we use to locate the corner holes. Okay, so you've got a big rectangle, which is the size of the block, and then you make a rectangle inside it, and on each of those corners is where you put the holes, the 4 holes. Line 12 selects the vertices of the rectangle, which we use for the centers of the holes. Okay, so the vertices are effectively lines perpendicular. The vertices, vortex, goes up from that corner, and then the hole comes down on that, I think. So let's just try that. Let's just zoom out a little bit. Get the code. That copy? Yeah. Okay, and then let's go back into Vim. Paste that in. So that's the same code that we were just looking at. So if we run it, error on line 10. Expected indent. Oh, because I pasted it, we've got some spaces there. I can remember how to do this properly. And then we do. Oh, there we go. Python. Let's run. Oh, exporters is indented, is it? What happened there? Invalid syntax. Oh, I see. Where I've copied and pasted. It's just add the bracket on the end, like it should have been. That's what happens when you copy and paste. Sometimes you miss the bracket off the end. Right, so run it, and let's view what we've made. Yes, there we go. Looks a bit like a CPU fan without the fan. Good, so we've got our countersinks. So you can see the countersinks, or the countersinked holes, are 12 millimeters in from each edge because of the padding that we applied. I'm not familiar with gmsh. No, let's quit that. Right, okay, so next, let's have a look and see what else we can get up to. Done. let's just make a note of what we've learned here. So we've learned that you use box to make effectively making a cube or a three-dimensional extruded rectangle. Faces, rectangle, vertices, C-bore hole. Filleting. Did we do filleting on this? Line 13. I was so busy doing the editing, copy and pasting. Ah, no. Right, let's add that in then. So fillet, please. And just need to go. Oh, what's it done there? It's put a pipe by. Okay, use a pipe with Z there instead of the elsewhere you've used the greater than sign. Need a backslash there. Don't think the indentation matters there, but let's see. So we should get the same result as before, but we should have a nice rounded corner all over the block. Yeah, you can see if we zoom in there, the other corner's been rounded. And that's happened in 4 places. Suppose we wanted to round some more corners, because I don't think it's rounded. No, it's not. Let's round some more corners, if we can do that. I'm thinking, let's do paste. And do the other backslash. And then we just want to go back to Z and replace that with in fact, we need to do that twice. Let's just do it with X. And then we need to do that with Y as well. So that will give us rounded corners on every edge of the box. Backslash again. Let's see what happens. Oh, there are no suitable edges for chamfer or fillet. Oh, I know what's happened there. That's because we've tried to run fillet on the corner as well. We've got fillet on a fillet. Let's go back and remove that then. In fact, could we? Let's remove the Z fillet. But I think this will work if we remove the Z fillet. Just a hunch. Yeah, right. What it's done is it's removed the 4 corners, the vertical corners. So it's removed the 4 fillets on the z-axis. Instead, you've got fillets on the x and the y. I'll show you. There we go. So we've got okay, it's actually rounded there as well. So we've dropped the x, sorry, we've dropped the y fillet. We've dropped the z fillet and we've kept the x and the y fillet. I mean, this is great. When you just imagine you were making multiple versions of this, and as I showed in a previous video, you can make this totally parametric. Well, the widths and the heights of the block for starters. Just reading the values from a CSV file, and I used pandas. So go back to the video where I called it how to make 3D models with Python. And there we go. Next, I need to learn how to fillet that cylinder in the middle. I suspect many of you are probably watching and think, why are you doing it like this? Because you could do it in FreeCAD and it would take 10 seconds. But yeah, it's always about trying to automate it and make it parametric. So always imagine, whatever you're coding, imagine that you have to do it 100 times or 1,000 times. You don't want to open up FreeCAD and do that 1,000 times and save it 1,000 times just because you've got 1,000 different products. Let's go back to the tutorial then. So we've learned about filleting and workplane edges. We've got some bits about exporting here. So STL, DXF, STEP. You can export it to whatever format you need. You want to open it up in AutoCAD, you'd use DXF. If you want to 3D print it, you'd probably use STEP or STL. Let's have a look at some more examples. Building profiles using, why is that? Oh, I've looked at that already. There we go. So that's what we just did. An extruded prismatic solid. So extruded means you've taken a 2D shape and you've just stretched it. By default, rectangles and circles are centered around the previous working point. Okay, so they've added a rectangle, and by default it centers itself around the center of the original circle. Wow, one line, that's nice. CQ workplane front, circle 2. So the diameter, is that the diameter? Or is it the radius? I think it's diameter, isn't it? Yeah, diameter they've used on that previous example. And then they've done a rectangle 0.5 by 0.75. Oh, did I miss a bit there? So the rectangle is extruded by 0.5 downwards. Let's just try that then. Let's just let's copy that into Vim, and getting messy, isn't it? It's probably a bit OCD to always want your screen clear, but I like it. Right, let's do NDD. And then just paste that in. In fact, let's just remove that as well. Let's go back to basics. Run this. We should end up with the same shape that we saw on their examples page. There we go. Oh, so that looks to be like a through hole. Okay. So I was thinking it was just an indentation. Looks like a Windows screensaver from about 1989. Right, let's start modifying this then, seeing what we can get. So oh, okay, right, so the rectangle is the same depth as the extrusion depth. So instead of 0.5, let's just extrude it by let's do 1.5 for the extrusion. Let's undo that. I just want to see what this does. I should really read the documentation, but right, what's that then? That's made the rectangle bigger. The rectangle's still going all the way through though, isn't it? So let's imagine we only wanted it to go part of the way through. Let's change that to 3.5 and see what happens. Okay, so 3.5, that's obviously the length. And the number that we were seeing that was 2, that's obviously the diameter of the circle. So rather than the radius. Oh, I see. It's actually extruding everything by the same amount. It's because it's all on the same work plane. To get a rectangle extruded by half of the thickness of the circle, of the cylinder, you'd need to set up a new work plane, I believe. We're learning about work planes. Right, let's look at arcs next. I'm really bad for skipping ahead. It's like if you open a book, and I always go to like not necessarily a fiction one, but a technical book. I'll always just open it halfway through. Building, finding an edge with a spline. Mirroring objects, geometry. Right, let's go back to where we were. Let's try and make this, what is it called? This example builds a prismatic solid from 2D operations. Oh, so we're building a 3D solid from an extruded closed 2D shape. So if you've used CAD before, you'll know that with polylines, you'll draw, if you're drawing a rectangle, you draw 1, 2, 3, and then you type CL for close, and then it closes the rectangle. So with CAD, you need to always close before you can close a 2D shape before you can extrude it. Right. Workplane front. Line 2. So 2. Or up. And oh, so that's length and then direction. So 2, 2. 3-point arc. Close. Okay, I think I know what that's doing. So it's going along, up, drawing the arc, then closing it, and then it's extruding it. So what you've actually got is 3 lines. You've got along, up, arc. Close is actually telling it that to close it, so that's actually completing the shape. Ah. If you saw ZZ there, that's because that's the better way to close a file in Vim. It saves you having to do Shift, colon, Q, Enter, and so on. Just do Shift ZZ, saves. So this should look like a very small slice of bread. There we go. So yeah, that was line 1, line 2, the arc, and then that line from there to there was never put in the code. It was close, just completed that. Okay, let's get rid of that. Right, next. API references. Workplane 3-point arc. So with the arc, you'll say the start point, the end point, and the radius, I believe. Line 2, extrude workplane. So this tutorial is really good. As you go along, it's kind of building upon the previous. In this example, a closed profile is required with some interior features as well. So each example adds a bit on. This example demonstrates using multiple lines of code instead of longer chained commands. Okay, so rather than having a big long convoluted one-liner with lots of dots, what they're doing there is a current point center to the circle. They've moved the work center, so that's where the next thing's going to start from. New work center is somewhere else, which is going to be there and there each time. Oh, so yeah. What it's done is what we're doing here is we're drawing a circle, a big circle. Then we're changing the origin, and then we're drawing a small circle there. Then we're tracking across over to here. We're drawing a square. And then the last bit, result.extrude. So we've got a circle with a small circle and a square as a 2D shape. And then we're just extruding it. Let's try that. So, there we go. So that was what we were just seeing on their webpage. So the big circle, the small circle, and the square are all going to get extruded by the same amount. Let's read that note. The new center is specified relative to the previous center, not the global. Okay. So if you go across 10, up 10, then to get to your new point, you just say go across 2, up 2. You wouldn't say go across 12, go up 12. Let's run that. I think we know what we're going to get. A circle extruded with a extruded circle and extruded square inside it. I think to learn it, you need to, here we go. Do these examples, modify it, break it, and there we go. In fact, if you wanted to make a smiley face, let's change, where's this, the rectangle. So I'm going to go up and I'm going to change this. What the? Stop it! The battery. I'm pretty sure it's because the battery's going on my mouse. Either that or the keyboard sticking. I don't know. So that's pretty much the same. Those two lines are almost the same. The only difference is it's moved across 1.5 since the previous one. I think that's going to give us quite an odd shape, but let's have a look. Yeah, so it's tracking across by 1.5 and then down by 1.5. I'm not an expert on STL files. To me, all of these lines and extra mesh bits seem superfluous, but for instance, if you were 3D printing this, you wouldn't want to keep tracking across between those. Anyway, we can look at file formats in due course. using point lists. Sometimes you need to create a number of features at various locations, and using workplane.center is too cumbersome. You can use a list of points to construct multiple objects at once. Most construction methods like workplane.circle and worktime.rect would operate on multiple points if they were on the stack. Okay, so what we're doing is push points. I don't know what push points is. Did we see that anywhere? Point lists. We're passing a list of XY coordinates. And we're drawing a circle at each of those, based on each of those points, and then we're extruding them. The push points is not actually doing a drilling or making a hole as such. It's just creating the location of each hole. Yeah, R equals R dot push points. So we're taking a list of 4 lots of X, Y, Zs, and then R equals those 4, and then we're doing our circle. So we're putting a circle at each of those 4 points, and then we're extruding it at the end. So to push points rather than point lists. Push points. ABD. Okay. So we're making a circle let's assume this is 2 meters in diameter. It's easier to visualize on a big scale. Big circle, then we're tracking across from the center, so we're going 1.5x. So we're going across 1.5, and then from there we're going oh, maybe it is from the center each time, is it? Yeah, those look like they're tracking from the center on each time. So if you imagine a clock face, from the center of the clock, you're going x by 1.5, and you're not going up. The next one, you're not going across, but you're going up. So on a clock face, this would be the 3 o'clock place, position. That would be the 12 o'clock on the clock face. That would be 9 o'clock on the clock face. And that would be 6 o'clock on the clock face. I know this might be sort of laborious, but it's very good to talk through it and understand what every single line does. Otherwise, you could end up making rubbish. Let's view that. There we go. I think I might look at how to export this in different formats soon, because I'm not really liking all of this, what looks like unnecessary geometry. let's see what other. Let's try a DXF file, shall we? I'm pretty sure I can open a DXF file with something open source. And this again. And let's see what we can open this with. Yeah, moo.dxf. Go on to Google DXF viewer. DXF viewer, Linux. I wonder what happens if we just search for apt-get DXF. Oh, of course, we could just open it in FreeCAD. Let's do FreeCAD then. And moo.dxf. Wow, it's made 14 shapes. And view. Oh, because I've made it outside of the FreeCAD GUI, it's not visible. So let's just somewhere here we can set visibility to. No. Ah, it was too big. Right. So shift, right click. Okay. That looks a bit nicer than when we do it with the STL file, doesn't it? So we've got, how many shapes? 14. So one, let's go through them. So shape is the actual, okay, it's that little green bit there. That's the extrusion. 2, 3, 4. Okay. And obviously, because this is DXF, you could import this into Blender, probably AutoCAD, SolidWorks, whatever. So DXF is drawing exchange format. Let's stick with DXF then, shall we? And let's see what else we can experiment with. You can create polygons for each stack point if you would like. Useful in 3D printers whose firmware does not correct for small hole sizes. Okay, so rather than drawing a circle, you just do a polygon with lots of sides, presumably. Ah, and they're using push points again. Oh, and there's a new command there, cut through all. Well, while we're at it, let's test that. Yeah. You ever do that in Vim where you end up typing KK because you've accidentally entered insert mode? Right, let's run that. What are we doing? Yeah, let's open up FreeCAD and see what we've got. I'm hoping we've got some hexagons. I'll actually turn on shading as well, and then it'll look nice. I have to zoom in and out to get. Where is it? Ah, there we go. And let's shade it, shall we? You. There's the viewer. what a wonderful banana that is. And I bet this doesn't work, but let's try anyway. No, it's not gonna find it, is it? I don't even know when this was last updated or anything, so. Come on, team viewer. Yeah, tried installing Debian but failed. Oh, LXV-viewer. Alright, let's try again. I need sudo. Unable to locate package. You need the OpenDWG toolkit. It just sounds like a lot of aggro. Let's go on Google. UDXF files, you know. I don't really want to be doing it online. Oh, LibreCAD. Yeah, we don't really want a CAD package as such. It's too bulky and cumbersome. Why is it talking about PDF viewer? I'll convert to PDF. Wine, Photoshop. It seems like it's a harder work, or it's more. it's more of a closed shop than I would have expected. I thought DXF was something that many people would have written converters for. eDrawings viewer. Yeah, that's what I used to use with SolidWorks. Let's have a look. That might be... Windows, Mac, iOS, Android. Maybe SolidWorks or Dassault Systems, who make SolidWorks. CAD. We don't really want to have to run CAD. Oh, DXF viewer for the browser. We'll look at that. In fact, what am I running? Chromium. DXF viewer. Should have thought of that to start with. Add extension. Then add it to Chromium. Click on the icon. Okay. We're going to have to go into this the hard way. What did I call it? No, that was yesterday's work. Look. Directory is this? Okay, let's check I've got DXF there, yeah. Oh, it's got a funny icon, that's why I didn't see it. Chromium web browser, that's default, yeah. It is kind of, what is it? Viewer for Google Drive, I don't want that. Okay, let's directly in your browser. Let's try this one then. Oh, sign up. No, thank you. This really sucks how everything has to be signed up to these days. What if you don't want to sign up to something? Right, there we go. Oh, it's not even letting you rotate. Oh, it's not. It's not letting you rotate it or anything, but Just zoom in and out. I'm really disappointed that there's not a really nice, easy to use viewer, 3D models viewer. Try this one. Edit the manifest file and remove the default pop-up key. Oh, just go away. Right, I'm bored of that. This is just such a waste of time. Right, let's go back to making something in cadquery. We know that we can work with DXF files and do stuff with them. Right, just before we give up altogether, I'm just going to open up. I think I've got Blender installed on here. I've got no idea which window that's going to open in, if at all it's actually even going to run. I don't know. Any sign of Blender? It looks like it was installed, but it's not opening, so no. Right. Polylines. Workplane polyline allows creating a shape from a large number of chained points connected by lines. So it's a bit like an Etch-a-Sketch. You start in one place and then you keep going all the way around. And then you type close at the end and it joins it up. So that's what we're going to do, is draw an I-beam profile and then we'll extrude it by the look of it. Yeah. So that's the extrude bit. Everything else is actually creating the shape of it. Okay, so we create a list of all the points, the push points. In actual fact, it's not the push points, is it? We're using the polyline instead of push points. Chain points connected by lines. Right, let's make that. We'll make that and then we'll modify it. We'll make it as a DXF and then we'll open it up in FreeCAD. You can tell it takes just slightly longer as you add more and more lines and parts. Not like the piece of Lego I made yesterday. That took about a minute to open. I can't remember how long it took to make. I think it took about a minute to make and about nearly a minute to open. Oh, there we go. I don't know why zoom to. I do zoom to fit. Go zoom. What's box zoom do? Need to go back to the drawing board. Well, yeah, back to school and learn a bit more about FreeCAD. Bit all. Yeah, oh yeah, VF. That's what I wanted. Yeah, right. Okay, so let's go see if we can add a bit of shading. Okay, this is where it falls over. This is what happened last time, wasn't it? Let's get rid of that then. Draw style, wireframe. It doesn't want to shade it. I don't know why. Is it because it's wireframe and it should be a solid? I think so. Which makes me wonder, let's instead of close FreeCAD, and instead let's does FreeCAD open in STL? And then we can try and make we can try and render that. STL, yeah, open in STL mesh. So I think we've got to the bottom of why DXF really is bare bones and it doesn't create a solid. So let's change that to STL. Make it. Open this in FreeCAD and then hopefully we can shade it. Oh, it's already shaded it for us. How nice. So yeah, a DXF will just give you a wireframe in FreeCAD. There we go, we've got our beam. So if you want to view it as a rendered, or if you want to render it in FreeCAD, then you need to got ray tracing there as well. I don't know how the rendering works, or even if rendering in FreeCAD is a good idea, but let's close that. Back to the tutorial. Defining an edge with a spline. This example defines side using spline curve through a collection of points. Useful when you have an edge that needs complex profile. Of course, what you could probably do is draw something in CAD in 2D, get the DXF file, get the points, and then you can work with it in cadquery. Or indeed, you could actually probably let's have a look at the cadquery. What's it called? Cadquery. The cadquery GUI. The thing that lets you visualize as you're actually modifying. CQ editor. Wow, it was modified yesterday, so that's always what you want to see. Still being supported. I know you can. I don't really want to build it. CQ editor. Let's try and install it then. Conda if you're used to sudo apt-get install and it takes 10 seconds, Conda is a little bit of shock to the system. Especially when it can't solve the environment to start with, and then it carries on and tries. You don't know if you're going to get stuck in a loop and you're going to be there forever, or if it's actually doing something. Best thing to do is go and make a cup of tea or coffee. Leave it to do its business. On that note, I'm going to go and get a brew, and then we'll be back and I'll see what's happened. And it's still doing something, so well, let's carry on. I'm just gonna have a slurp of this brew. And if you're thinking, why is this geezer so incompetent at solid modeling, and how come he doesn't know how to open a DXF file and so on? I last used CAD solid modeling as one of my first jobs, and I forget which operating system it was. It might have been Windows ME even. If not Windows ME, then Windows XP. And I used SolidWorks, not an unofficial copy, sorry, it wasn't pirated, it was a spare copy. And even back then, I think it was about £4,000 per seat. It was with CAD software, they call it a seat. So it's before the days of transferable licenses and so on. So there were two paid licenses within the company. One was used by the man who controlled the CNC machine, and the other copy was spare. But when it was not in use, we had to have USB dongle in the back of the PC. But because it was so expensive and it couldn't be replaced, or I don't know if it could be replaced, but maybe it was just perceived as being a high value piece of kit for insurance purposes. The dongle was actually kept in the safe. Wow, I don't know how long that was. That was quite an age, wasn't it? Cryptography. I remember that. I had to install cryptography on my Raspberry Pi to get something working a while back. I forget what it was. It might have been. It wasn't Scrapey. I can't remember, but cryptography was one of the stumbling blocks in trying to get something up and running on my Raspberry Pi that I'd already installed on my main Linux distros elsewhere. Can't for the life of me think what it was. No, might have been when I was trying to get private VPN, or I was trying to get some VPN going. But you would have thought that would have already been taken care of, but right, what's the it's installed anyway, so what's the syntax? Maybe it just is CQ. Okay, CQ editor. Well, anyway, if this works, then we'll use this. But hopefully you've seen so far, to automate something, you want it 100% command line, and that's what we've done so far. This that we're about to do, fingers crossed if it works, is what we will do to actually create the model that we will then put into our code. And so really this is the build stage. We'll build something in this, we'll identify what we're going to make parametric, and by the look of it we'll have a nice window here which will give us our code, and then once we've got our code, that's what we will run on a highly repeatable, highly automated basis. So I don't know about you, but that font's probably just to do with just making it slightly bigger. Bigger, not smaller. $14. Yeah, that looks about right. Color scheme, right, is it? Object tree, debugger, 3D viewer. Okay, so what we're really doing here is this is exactly what we've been doing so far. The only difference between this and what I've been doing manually with my cq2.py file is this is just going to display what we're building in real time. We just do more cq, and just to show you this, what I'll do is if we run cq2.py, so that was all of the code that was doing the import. It was importing the exporter, if that makes sense. That's the bit that saves it to a file. So that's what you really do need if you're going to automate this whole process. And obviously the file name you would make dynamically. So as you saw in my last video where it's being read from pandas, which was, well, not say pandas, pandas was allowing me to import a CSV. So there we go. What we now need to do is just get this bit and transplant that into here, and hopefully there we go. We've got the very same I-beam that we wrote in Python with cadquery and we opened up in FreeCAD. Right. I think we'll stick with this for the time being. What I've kind of hopefully illustrated is that using Vim, cadquery, Python, you can actually generate 3D models. And this is basically a tool to allow us to pair the code. So, to be honest, this is going to be a lot better for modifying. Look at this, instant. Right, and instead of being half the thickness, let's make it whatever that is. Oh, that's broken it, so this is going to be a lot better for making and breaking things. Oh, and it's not like that either. So thinking about this is making length, height, width, thickness. If we make this thicker, yeah, big chunky I-beam, and then once we've done that, hopefully we can, let's just, instead of points, extrude by the length. There we go. So it's a lot smaller. Our helpers is just seeing the axis. Let's have a look at what else we've got here then. So parameter. I think this could be potentially useful. Cool. I think we've... What happens if I type this here then? Let's call it I-beam. Let's save the code. I-beam. I just want to see if that parameter actually gets passed through into our file. No, so that's what it just made. I don't know what the parameter bit is going to do for us. Objects, parameter, value. Oh. Could always consult the documentation. To be honest, this is really just a tool to help to build our model that we're going to repeat over and over again with Python. I know. Let's strip some of this out. There we go. So this last bit is doing the extrude. So it's a given that we're making an extruded object. So what we're doing is we're starting from 0 and then we're going by height divided by 2, which is 40. So that's 20. So we're going from 0 to 20, and then we're going from 0 to 20. We're going width divided by 2. So that's 20 divided by 2, so that's 10. Then we're going 10 up. Sorry, 10 across rather. We're making a triangle. I'm just thinking, is there a way how we can use close? What was that? Let's go back to... We don't need this anymore. Let's go back to where we were in our tutorial. And I was, we were at polylines, weren't we? So take with whole, we don't want that. Current working point. Polylines, polygons. Point. It's there somewhere, isn't it? Polylines, workplane, polyline. So I think the point I was trying to make earlier was that if you use a polyline, you need 1 point less than you're actually making. Demonstrate that. So go north, go along. Naught. So that's x is naught, y is up. Let's take out these. So go up, go across. Creating a triangle, it's closing it. Yeah, because it needs more than this. I'm going to take this out. Right, so let's go. X is 0, and we're going to go 2 up. And then from 0, 2, then we'll go across by, let's do 3, 3. And then I think we need to do 2, 0. L is not defined. Oh yeah, extrude. Wow, what a shape. That's not quite what I was expecting. Oh, it's mirroring it as well. It's mirroring the shape. Yeah, okay. Let's go for some mirror X. Hollow is, well, it looks like it's hollow. I guess depending on what you export it as will then influence whether it's a wireframe or a shell or a solid. I don't know. If anybody knows that, then drop me a comment. Right, I'm going to take out mirror. Basically, let's just deconstruct this. So it works when you mirror it, but when you don't mirror it doesn't work. Okay. Tuple object is callable. Oh, we need a comma. Wow. So let's how do we get this? There we go. So we go from the 0, 0, we go 0 along, 2 up. Okay, and then what's that point? So is that point 3, 3? And that point's 4, 4. And that point. Oh, so these are which way round is it? Is it Cartesian or the other one? Absolute. These are absolute. So if we added if we change that 2 to 3, that should square it off. Yeah, there we go. And if I change that to 4, change that to 4, change that to 4. We've got double, we don't need that anymore. So there we go. And this is making more sense now. So 0, 0 is taken as a given. So then the first line is 0, 4, which is there. And we've got 4, 4, which is there. Then we've got 2, 0, which is there. And then because there's a polyline, it closes itself, which takes us back to there. So if we take out mirror, I still want to get that to work. Let's put in 0, 0. I think maybe if it's polyline, it does need that fourth. No pending wires present. Wow, we've broken it. So you've got to have that mirror there to get it to close itself. Wow. What does this do? Export as step deal. Screenshot. Render. Yeah, I didn't think it was going to be high quality rendering. That's not really what we want. Rendering takes forever, and till your model's perfect, you don't want to be wasting time rendering things. Right, let's go back and carry on with the examples. Where did we get to? So the spline, SEN. So again, it's another list of XY coordinates. And then we do S.line. Okay, so our work plane, line 2, go up to 3, 0, 3, 1. And then it's putting all of those in between, I think. Close. Let's experiment with this then. So go on this, and we've got a nice shape. What would be good to do with this would be to rotate it, revolve it, and then you've got a potential candlestick or a some sort of fruit bowl or whatever. Okay. So let's change from 4. Will that just make it taller? Yeah. Then, okay, let's go 6. So we're stretching it, and then the spline is adjusting to match, I believe. Or is it? I think we've broken it. Yeah, we've broken it. Let's go back. What was that? 3? 3 to start with. Yeah. So 3, 0, 0. 3, 1. We're looking at it the wrong way around. So, does this let me view the points individually? That would be good. There. Tools, run, debug. Ah, there we go. Debug, step in, continue. Right. Oh, can we have break? Oh, wow, we can have breakpoints and everything. This is amazing. Right. I won't render, I won't debug. So, step in. Oh, is it? So S dot, I'm just curious about this S dot line 2. So you start at 0, 0, you go 3 along, 0 up, and then you go from 3 along up to 1, and then you do a spline all the way back. Okay, that makes sense. In fact, I'm looking at this the wrong way around. Let's So we start at the axis origin here, then we come this way by come down here by 3. So we go from 0, 0, we go to 3, 0, and then we go from 3, 0, we go up to 3, 1, and then we go up to 2.75 along from here. So 2.75 up to 1.5, and we go 2.5 up to 1.75, so that's the highest point. And then we come back to 2 and 1.5. So if we want to make this dip more pronounced here, then we need to do something like the halfway point, which is 1.5. Let's make this 0.8. And that should make this dip come down a lot more in here. Yeah, there we go. And to make it even more pronounced, let's change it to 0.4. There we go. Next, 0.5 along is 1 up, and 0 is at 1. So if you wanted to bring this endpoint down as well, we could bring. Well, actually, no. Let's make it go up. So instead of 0.1, we'll take it up to 0.1.5. There we go. So you can see we're building a 3D model, and we've got complete control over it programmatically. But this is good. We've learned how to use the spline. Next, we need to. What do these do? Shaded wireframe. Okay. And just to go back over what we were doing earlier, let's take this out and let's just transplant this back into our Python code, command line Python code. Let's do vim, and what we're going to do next is going to be nice, because I'll paste this in, and then what we can do is we can link up the shape of that spline. We could potentially link that to a CSV file. So depending on what the CSV file contains in each line, it could have a sequence of values which tell us the shape of the spline. So if you want, for instance, if you were making these components to order, you could provide your customer with the option to upload their own STL file. You could pass the STL file. No, sorry, you don't even need them to supply the STL file. You just tell them what shape, or you get them to describe their spline, and you could presumably you could do this in JavaScript. They could design their spline shape. You could capture those coordinates and then save those coordinates into a database, process every row in that database. Each row will then get fed through this file, because what we'll do is each of these will become a variable. So we would call this x1, y1, x2, y2, x3, y3, and so on. Then, having read those values, you would then run cadquery 2.py. You would end up with loads and loads of STL output files, and then you could then manufacture those on your 3D printer or your CNC machine. Much as I pretty much showed in the previous video. In the previous video, I was just making cubes of different dimensions, whereas here we can make customized shapes based on the spline, the spline X and Y coordinates. So let's save that. What's going on here? Oh, Conda. So this is why sometimes it's good to have live code, because you see all the things which other people kind of gloss over when they're doing you know, a sleek, glossy 5-minute video. So right, now let's run Python cadquery. So if you're not familiar with Conda is how you can have different environments. It's a bit like pip what's it? VENV. Conda's gradually becoming more and more popular, and obviously Conda is it's used. You can use it in VS Code in Windows as well. So what are we doing now? Let's view. gmsh mu.stl, and there we go. That's our spline, everybody. So we've created a rather splendid shape. But each of these values can be, the peaks and the troughs can be read from, they can be read from a CSV or a database, and obviously that data can be, you can get that from anywhere. You can get it from a customer. Imagine you could create a 3D model on a 3D printer of COVID. So COVID cases could be the the x-axis would be time. So that'd be January, February, March, April, May, so on. And then y coordinates would be the number of cases of COVID. And you could make a 3D model of COVID cases. And then you could send it to the government and they could put it on their windowsill to haunt them for their gross incompetence. Oh, did I just say that? Sorry. Sorry for nothing. Sorry for telling the truth. Should we do that then? Should we make a 3D model based upon COVID? So let's get some COVID, but it's stats UK. Daily. Cumulative data. I want. Okay, download card data. Let's get it as a CSV. What we'll do is we'll then manipulate it a little bit just to, in fact, could have done this with pandas if I thought of it. Wow. That's how many dates is that? So that's going from the 30th of January. Okay, so that's over a year and a half worth of data. Right, instead, let's just do it for July. I think that's going to give us a decent new cases by. It's gone from. Right, just bear with me on this. I'm just going to get rid of everything from July back, from older than July. This is why I don't like spreadsheets. They're just really annoying to work with. Right. Area code, we don't care about that. Delete column? Yeah. Delete that. New cases, cumulative cases. We don't care about cumulative cases, not for the sake of what we're doing. For the sake of the human race, we should, but Right, let's save that, and we'll save that as a CSV, which it already is, and we'll save it into FreeCAD current. And we'll call it cv.csv because that stands for coronavirus.csv. Fact. Let's change. Let's get rid of those. We need to clear the contents. Clear contents. And if I put one in there, that's, oh, why is it? Does anybody know how you go from 25 down to 1? Oh, please don't make me do this manually. Let's format cells. Date. I think we might be able to just put in the format cells. Date. No, why is that? It's not formatting it. Not doing anything. Right. So this is the date. This is the day of July. So what we're going to end up with is a spline representing COVID cases through July. And we're going to get Python to make a solid model of this. And then the solid model could then be manufactured on a 3D printer or a CNC machine of some sort. Date. Save. Okay. Right. So let's come out of that. And to be honest, what we could, import pandas as PD. Just check that's not going to break it. Good. df equals pd dot read underscore csv and cv dot csv. You're working? Yeah, good. And but all of that needs to go in. S point. So we need to convert our data frame into something that S points will understand. Do J equals length of df. So that finds how many rows we've got. And then we'll do for I in 0 to J. Let's just do print. Oh, let's just do print I to start with. Did we get console output on this? Console, what? Console, why are you not showing us anything? Oh, you need a range. Why is it not? Okay, right. So we'll go for df date df ilock Let's take all of this and run it in Jupyter Notebook to start with. So I think we're going to have to install Jupyter Notebook into this Conda environment. I think. Oh, no, we're in luck. Okay. So we print the date and let's print. Now what was the name of the second column? I might just go and rename it to something a bit more user-friendly. Oh, and I need to delete column A as well. Delete column. Let's call this cases. Run that. There we go. So, yeah, but so x equals y equals Okay, so I had to create a list of tuples. So in the list, length of data frame. So then we can iterate through our data frame and going to get date and the number of cases. Then we're going to make a tuple of date and cases. And then we're going to append that tuple to the list. And then we're going to print it just to check it. There we go. So this, so then we will have. Okay, so we're going to leave it there actually, because I've realized that the data from the COVID site was actual values and they need to be relative values for this to work. So thanks for watching, and I'll be back with something very soon.